Hello everyone, and welcome to our next video here on Unit 4, System of Linear Equations and Inequalities. Topic 3, we're going to be talking about solving systems of equations by elimination. And our learning target is to solve and write a system of linear equations in two variables by elimination. And the essential question is, how do we solve a system of linear equations by elimination? So here's our vocab that hopefully make sure you guys write these three definitions down. We talk about coefficient. We're talking about the numerical factor when a term has a variable. Basically, it's the number that's in front of the variable. Elimination, meaning that you add or subtract the equations to eliminate a variable. That is the elimination method. And then when we talk about opposite, we're talking about coefficients that have the same number but different signs. An example I've given here is 3x and negative 3x are opposites. Notice they both have the same 3, but one's positive and one's negative. This is going to be super important because by being able to do this, we're able to eliminate the variable. So the big idea that we have sometimes is not easy to use substitution to solve a system of linear equations. So you might need to multiply one or both equations by a constant to get like coefficients that are opposite to use elimination. And also remember, when you multiply by a constant, all the terms get multiplied by the same value. It's not just one, it's all the terms. So, solving a system of equations by adding. So this is elimination, so our point here is to try to add this together. So to find the solution to the system of equations. So already here we have what we're looking for. So if we look here in these y's right here, notice we have a positive y and a negative y. That's opposite. So we can go ahead and add these two together. X and 2x added together gives you 3x. 7 plus 2 gives you 9. And if you add the plus y and the negative y together, you get 0. So 3x is equal to 9. You divide by 3. X is going to be equal to 3. And then what you would do is, it doesn't matter which one again. I'm just going to go ahead and choose the top one. I'm going to substitute 3 in for x. And I'm going to solve for y. And my solution is 3, 4. So the next example that we're going to go over here, we're going to understand equivalent systems of equations. So understanding what that means. So we're going to look at this solution, the system of equations. So notice, unlike in the first one, we don't have that easy, hey, we're going to multiply, we can add this up right away. Now, looking at this, the one that would be able to do the quickest is try to eliminate x. So in order to, before we add the equations, we need to multiply the first equation by negative 2. So when we do that, I'm just going to show it down here. All the terms need to be multiplied by negative 2. Cannot understate this enough. Everything gets multiplied in that first equation by negative 2. So now we have this. So the result here is, once again, like what we were talking about before, this is an equivalent system. The result is an equivalent system that has the same solution as the original. This is because the first equation has the same solution after multiplying each side with the same non-zero value. Negative 2x plus minus 6y is equal to negative 14 is the exact same as x plus 3y is equal to 7. We just multiplied everything by negative 2. Now we're going to solve this by adding. So now we can be able to add both of these equations together. So adding negative 2x and 2x together, that disappears and gets to 0. Negative 6y plus 2y is negative 4y. Negative 14 plus 6 is a negative 8. Now we're going to divide both sides by negative 4. Y is going to be equal to 2. Then I'm just going to take one of these and I'm going to substitute it in. I'm going to use the second one this time. And I'm just going to substitute in 2 for for y, because I'm writing it down on the screen. So 2x plus 4 equals a 6. That's what's on the screen here. I'm going to divide by 4 on the screen. So then we have 2x divided by 2. X is going to be equal to 1. 1, 2 is our solution. Now this one right here, we're going to apply elimination. So this one's talking about a florist making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many each type of bouquet can the florist make? So we know that in a regular bouquet, she can use 5 roses. And 3 roses in the mini, and only has 118 to use. So this one, we're just looking for the total number of roses, so we got to look in the regular and the mini. So R is regular, and M means mini. So then the other one, we're going to have 11 and 5 peonies is equal to 226. Now we got to figure out how to, of course, solve this by elimination. Really, the only way we can do it is we're going to have to multiply both equations by a non-zero number to get one to cancel out. And the one we're going to choose is M. You can choose to do R, but I'm going to do M. And one of the ways you can do it is you just multiply by the opposite coefficient. So you're going to multiply this one by 5, and then you're going to choose to multiply this one by negative 3. One of these you have to multiply to be negative. So now you have 25R plus 15M is equal to 590. And then the other one is going to be negative 33R minus 15M is equal to negative 678. And if you're freaking out, don't worry, this will come out to be a positive number. So if negative 8R is equal to 88, negative 88, then we're going to divide negative 8 to both sides. And we see that the regular bouquet is 11. So then what we're going to do is we're going to just take that number, and that just gets substituted back into one of the original equations. So you can just use one of the regular equations. You don't have to use the one that you multiplied by 5 and negative 3. You can just go back to the original ones and just set them equal to find M. Then we're going to subtract 55. That's just going to be 63. Then we're going to divide by 3. And M is going to be equal to 21. So you can make 11 regulars and 21 mini bouquets. Now, since we've reached the end of this, we can now go through and choose a method to solve. So we know how to solve by graphing, we know how to use substitution, we know how to use elimination. Now we've got to determine what's the solution to the system of equations. So to determine which method would be the best one to use, sometimes you just got to look at the problem. Say for this one, if the solution of the system of equations, if you already know you have one of the variables solved for, go ahead and use substitution. Would you use elimination on this one? you would have to rewrite it in order to make it work. So instead of going through and rewriting this first equation or rewriting the second one, it might be easier just to do substitution. Or just substitute this in for y. Again, like I mentioned in the previous video, don't forget about the parentheses. Two x plus 7x is 9x, plus 91 is equal to 10. Then we're going to subtract 91 on both sides. We have 9x is equal to negative 81, divide by 9, and x is equal to negative 9. And then we're just going to take that and substitute it in up here. And we get 9 plus 13, y is going to be equal to 4. Then this one, since we don't have the variable solved for, so we can see how they're both written in standard form, this would be the good one to use. Elimination. So it would be useful to multiply this one by 2. So this one we can make 16x minus 4y is equal to 16. And then this is just 5x plus 4y is equal to 17. Sorry, I didn't mean to write that on there. So yes, you're going to add all this up. This is going to end up being ugly numbers, but that's okay. Not in the business of making this pretty sometimes. So x is going to be equal to 1 over 21. I know I can already hear the screaming in the background, being like, oh my god, this is such a bad fraction. But we'll just make it work. So this is 8 over 21, now that we substituted in. And now we just need to add or subtract this over. So then we're just going to rewrite negative 8 as negative 168 over 21. So that way we can subtract 8 over 21 on both sides. That way we got 176 over 21. And then we just divide this by negative 2, which means we can just multiply. Well, then this just continues to get uglier and uglier, but that's okay. Then this just becomes 176 over 42. Yeah, I know this one was painful, but we'll make the most of it. So then the last part here, so remember this is just the kind of the main concept that you guys should get when doing these types of problems. Go ahead and work through the try me problems as soon as you get done with these notes, so that way you can complete them and make sure you turn them in for points. And I'll see you at the next one.